Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim Shah. So today, my group, which is Group 5, wanna present about fuzzy controller in a warm water plant for our subject ISP 568, which is fuzzy logic system. Then this is my group member, Muhammad Izzi bin Muhammad Zaki, Muhammad Alif Imran, Muhammad Alif Najmi, Muhammad Aziz Izzuddin, Muhammad Alif Faisal, and me, Muhammad Hakim Shah.
Introduction. Fuzzy controllers can adjust the temperature of the water more precisely and efficiently than traditional controllers. The process of designing a fuzzy controller for a warm water plant involves selecting appropriate input variables, membership functions, and rules. When a fuzzy controller is utilized in a warm water plant, it can lead to improved energy efficiency and more accurate regulation of water temperature.
Hello everyone, my name is Alif Najmi bin Ahmad Bakhari and I will explain about the objective and the scope of the fuzzy controller in a warm water plant. So, for the objective of a fuzzy controller in a warm water plant is to regulate and maintain the temperature of the water within a desired range. In the context of a warm water plant, the fuzzy controller would receive inputs such as the current temperature of the water, set point temperature, flow rates, and other relevant parameters. So here we have 5 objectives of the fuzzy controller of warm water plant. So the first one is temperature regulation. The fuzzy controller aims to regulate the temperature of the warm water in the plant, ensuring it stays within a specified target range. This range is typically determined based on the requirements of the specific applications or process that relies on the warm water. Okay, another objective is energy efficiency. It is to achieve temperature regulation while optimizing energy consumption. The fuzzy controller can adjust the operation of heating or cooling elements in the plant to minimize energy usage while still maintaining the desired temperature. Next, we have the stability and responsiveness. The fuzzy controller should provide stable and responsive control to changes in the system. It should adapt to variations in input conditions such as fluctuations in the incoming water temperature or changes in the water demand and make appropriate adjustment to maintain the desired temperature. So for the fourth one, we have the robustness. The fuzzy controller should be designed to handle uncertainties and disturbances that may arise in the system. It should be capable of maintaining temperature control even in the presence of noise, measurement errors, or external factors that affect the water temperature. So lastly, we have the safety. The fuzzy controller should ensure that the warm water plant operates within safe limits. It should prevent the water temperature from exceeding critical thresholds that could pose a risk to equipment, processes, or personnel. So, next, moving on to the scope of a fuzzy controller in a warm water plant. The scope of a fuzzy controller in a warm water plant refers to the specific areas and functions within the plant where the fuzzy controller is intended to be applied. The scope can vary depending on the plant's design, size, and requirements. So here are 6 scope of the warm water plant fuzzy. First one, the temperature control. The primary scope of the fuzzy controller is to regulate and control the temperature of the warm water. It monitors the current temperature and adjusts the operation of heating or cooling elements to maintain the desired temperature set point. Second is flow control. In addition to temperature control, the fuzzy controller may also be responsible for regulating the flow rate of water within the plant. It can adjust valves, pumps, or other devices to ensure an appropriate flow of warm water through the system. Next, we have sensor integration. The fuzzy controller may integrate with various sensors throughout the plant to gather data about the water temperature, flow rates, pressure, or other relevant parameters. It uses this information as input to make control decisions. The fourth one is alarm and safety systems. The fuzzy controller can be linked to alarm and safety systems within the warm water plant. It can monitor critical conditions such as high temperatures, low flow rates, or equipment failures and trigger appropriate alarms or shutdown procedures to prevent any potential hazards. Uh, Next, we have energy optimization. The fuzzy controller may include features to optimize energy usage within the warm water plant. It can adjust the operation of heating or cooling elements based on real-time conditions, demand, and energy efficiency considerations. Lastly, we have system adaptation. The fuzzy controller can adapt to changing conditions or variations in the warm water plant. It can handle different operating modes, variations in water supply, or changes in user requirements by adjusting its control strategies accordingly. That's all for the scope. Thank you.
Now I will present about advantages of fuzzy controller in warm water plant. First, it will help to make good efficiency in control policy by operator. The use of fuzzy set theory in such an investigation is self-evident. In their control application of fuzzy set theory, they achieve a successful control of a small boiler steam engine combination, even better than a conventional DDC controller. Next, we can discover linguistic rules in fuzzy algorithm. These rules obtained by an experienced human process operator. For example, if increase in temperature is big, then decrease pressure a lot. Else, if increase in temperature is low, then decrease pressure a little. These linguistic rules will help other operators to have a good care on their warm water plant. For the third advantage of this topic is that it can optimize the performance of the warm water plant, reducing energy consumption and increasing energy efficiency. This can help to save money on energy bills and reduce the carbon footprint of the plant. Finally, fuzzy controllers can be customized to suit the specific needs of a warm water plant, providing flexibility and adaptability to changes in input conditions or output requirements.
Okay, now we explain about the disadvantages of using the fuzzy controller in the warm water plant. Okay, first, there will be inaccuracy of data. The system may work on inaccurate data that input that is provided by human. So the system may not work as we intend it to do. And the second one is dependent on human knowledge and perspective, as because the efficiency of the system will not be high, as there are always be a human error in the system. And next, the controller need to be readjust. Uh, the controller will be need to be update regularly so that it can maintain and be functional and be efficient. And the last one is the settings. The sensitivity of the settings may be changed to surroundings because not all day will be the same. Will be the same type of surrounding. It may be warm, it may be cold, so the settings may not be suitable in accordance to the surrounding.
Assalamualaikum, my name is Izzy and I will talk about the process. This fuzzy system concept has been applied to design a control for the temperature of a warm water plant. The warm water tank is divided into several compartments. The cold water stream enters the tank with a variable of F2. This water is heated about 90 degrees Celsius, flow with a variable flow F1. It changes to F1 if it heated. Usually, a constant amount of liquid of a certain temperature is required from the process. So the flow of F2 has been to keep constant during steady state. To get competitive idea of the performance of the fuzzy controllers, and ordinary Pi controller has been implemented as well. Pi controller has been optimally adjusted for an experimentally fitted model consisting of two equal time constant and time delay. Time delay is 10 seconds and the time constant is 40 seconds. The optimally value of the integral gain k and proportional gain kp for three different integral area criteria. As you can see the table above, optimal K1 and Kp value for a digital pi controller. This is for sample time 1 second. One of main difficulties of this controller was it need adjustment to operate over a wide range of desired temperature. It is clear that a more sophisticated controller with a stochastic and adaptive model than just pi type could have a better performance. Hence, the comparison between the pi controller and fuzzy control should be regarded as only a rough indication of relative performance. Next, I will talk about the algorithm. The described fuzzy controller resulted in the following algorithm. Every rule I associated a fuzzy flow FL subset to a fuzzy temperature T subset represented by their membership function. The first formula there, the actual action applied FL0 can be computed from the measured temperature T0 as follows. The membership value of the temperature T0 are determined for each rule. The second formula, the implied fuzzy subset for the FL has a membership function that can be calculated for a rule as the third formula. The result is a fuzzy subset which range over all value of the flow as the action taken at the maximum value of the membership. It can be determined directly by taking the value of the flow FL0 for which the following hold. The last formula, which is max and min formula.
So for our framework for warm water plant controller is the first one is falsification, which is come from input from the users, such as the workers and the computers, and directly to inference system, which is the system that who makes the decision between them. So the one that connected to the inference system is database, which is the data from our previously model previous models that contains cold, warm, or hot water temperature, and then from the inference system connected to our rule base, which is the algorithm that my friend Easy has already explained from the previous slides, and then the falsification, which is the system output such as system monitors and water sprinkler that uh, what plant that spring the water to the plant.
In conclusion, preliminary research suggests that fuzzy controllers have similarities with proportional and integral actions. Fuzzy controls unique control algorithm based on fuzzy set theory in a significant contribution despite being essentially non-linear. Fuzzy linguistic rules can incorporate a human operator's experience, making it ideal for complex operator-controlled processes.